wherein it is study of the geophysical process that causes earthquakes and its various effects, wherein it also said that it is an interdisciplinary branch of engineering that designs and analyzes structures such as buildings and bridges. Also, we have discussed some terminologies like seismology, wherein it is study of the generation, propagation, and measurement of seismic waves through Earth and the sources that generates them. It comes from the two Greek words of seismos and logos, wherein seismos, which means earthquake, and logos, which means science. Also, we discussed about the internal structure of the Earth, the layers of the Earth, the inner and the outer core, mantle, and crust, wherein mantle is the thickest among the layer. Also, we discussed about continental drift and plate tectonics. Specifically, we discussed the theory of convection, wherein scientists believe that tectonic plates move because of convection currents that flows up from the core of the Earth and circulate under the asthenosphere. Also, we discussed the 7 major plates and the 7 minor plates, the magnetic seafloor mapping, the hotspot, and the geodetic survey. And lastly, we discussed about the different seismic hazards, wherein structural hazards considered to be the deadliest among the hazards. And as of now, I would like to give the floor to the next presenter, Cheryl Lee.
So, good afternoon po. So, every one of us know what will happen if earthquake occurs. So, before that, what is an earthquake? An earthquake is what happens when two blocks of the earth suddenly slip past one another. The surface where they slip is called the fault or the fault plane. The location before the earth's surface where the earthquake starts is called the hypocenter. And the location directly above it on the surface of the earth is called the epicenter. So yon, ang earthquake daw po ay nangyayari kapag ang dalawang bato or yung dalawang blocks sa ilalim po ng lupa ay nag-slip sa isa't isa or nagdaplisan. So yon, doon po nangyayari yung tinatawag po nating grounding of the earth's surface or yung tinatawag po nating earthquake. Or sabi po ng iba, yun din yung sinasabi na pagyanig ng lupa na nagdudulot po ng pagkawasak ng mga structures or ari-arian po dito sa mundo. So next slide. So yun. The Earth has 4 major layers, the inner core, the outer core, the mantle, and the crust. The crust and the top of the mantle make up a thin skin on the surface of our planet. But this skin is not all in one piece. It is made up of many pieces like a puzzle covering the surface of the Earth. And not only that, but these puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates. And the edges of the plates are called the plate boundaries. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plates keep moving. Finally, when the plate has moved far enough, the edges unstick on one of the faults and there is an earthquake. So yun, aware naman po tayo na merong 4 major layers ang Earth since primary dahil napapag-aralan na natin. So to make this slide short, the mantle, yun po yung tinatawag natin na thin skin. Pero hindi dahil thin skin, maliit lamang siya. Pero yung mantle po is made up of many parts. Yun, sabi nga sa slide, kinompare siya sa puzzle. So yun, the puzzle is called the tectonic plates and the plates of the edges is called the plate boundaries. So yun, we do not know pala na doon pala nangyayari yung earthquake dito sa mundo. And since the plates are very rough, so yun, sila po ay gumagalaw ng napakabagal sa isa't isa. Or minsan sa isang taon, 1 kilometro lamang ang paggalaw nila. Pero kahit ganon, malaki pa din po yung dulot nun at isa din po yun sa halaga ng deformation na nagre-resulta ng paglindol or earthquake. So yun, third slide. So ito po yung pinaka-main topic. Ano po ba yung 5 main causes of earthquake, or ano ba yung dahilan kung bakit nagkakalindol? First one is volcanic eruption. The main cause of the earthquake is volcanic eruption. Such type of earthquakes occur in areas with frequent volcanic activities. When boiling lava tries to break through the surface of the earth with the increased pressure of gases, certain movements caused in the earth's crust, movement of lava beneath the surface of the earth can also cause certain disruptions. This sends shock waves through the earth, causing damage. These earthquakes are mild. Their range is also limited. However, there have been certain exceptions with volcanic earthquake bring havoc and death to thousands of people. So yun, isa po sa dahilan ng paglindol ay ang mga pagsabog ng mga bulkan. So aware po tayo sa nangyari sa Taal Volcano. So yun, nangyayari lang po ang paglindol doon po sa part ng madaming volcanic activities. So yun, dahil po, or sabi nga, yan, nag-search po ako, sabi doon, dahil sa pagtaas ng pressure ng gas na nagdudulot ng paggalaw ng Earth's surface, yun, sinasamahan po or natitrigger yung lupa, and doon po nagsisimula yung cause, or doon po nagsisimula kung bakit sumasabog. And yung mga bato po sa ilalim, doon po nagkikiskisan or nagkakabanggaan, yun, nagkakaroon po ng ground or nagga-ground po yung environment, and nagre-resulta po ng pagkamatay ng maraming tao. So noted, iwas po tayo sa pagtira malapit sa bulkan. So next slide. So yun, tectonic movements. The surface of the earth consists of some plates comprising of the upper mantle. These plates are always moving, thus affecting the earth's crust. These movements categorize into three types: the constructive, the destructive, and the conservative. Constructive is when two plates move away from each other. They correspond to mild earthquakes. When two plates move toward each other and collide, this is known as destructive plate boundaries. And this is very destructive. Conservative corresponds to passing by of plates of crust, and earthquakes of this type have varying intensities. So yun, tectonic movements categorized into three parts. The first one po is constructive. So yun, ibig sabihin, if yung dalawang bato or yung dalawang blocks ay naghiwalay or naglayo sa isa't isa, matik, there are possibility that mild earthquakes occur. Ibig sabihin, hindi pa siya sobrang worse or delikado. Pero isa siya sa type ng movement sa tectonic. Ang pangalawa naman po ay ang destructive. So yun, from the word itself, destructive, ibig sabihin, malala or worse yung dulot nito sa atin. So yun, if yung dalawang bato or yung madaming bato sa lupa ay nag-collide sa isa't isa, nagkabanggaan, nagdadaganan, ibig sabihin, malaki yung dulot na sira nito sa atin. And last is the conservative. Conservative, it is just passing by the plates on the Earth's surface. So yun, familiar naman po tayo sa intensities ng earthquake, di ba? Yung intensity 1, 2, 3, 4, 5. So yun. So to make this tectonic movement na slide short, if ang mga bato po ay nagsama-sama or tumitigil po sila, yumayanig, nagaground, ibig sabihin, unti-unti pong tumataas or nadadagdagan yung pressure, at kapag tuluyan na bumitaw po yung pressure, tectonic movements occur. So the third causes is geological faults. A geological fault is known as the displacement of plates of their original plane. The plane can be horizontal or vertical. These planes are not formed suddenly but slowly develop over a long period. The movement of rocks along these planes brings about tectonic earthquakes. These faults occur due to the impact of geological forces. The displacement of plates creates the fracturing of rocks, which releases a lot of energy. This type of earthquake can be disastrous. So yun, ito naman po yung fault, or ito naman po yung causes na sinasabi na nag-iiba yung posisyon ng mga plates compare po sa original position. So yun, doon po sa, for example, doon po sa mga malapit sa dagat, di ba pansin natin yung mga lupa is karaniwan puro mga nakaslide. Wala naman tayong nakikita na mga bahay-bahay na puro yung daan is tuwid. Puro sila nakaslide. So ibig sabihin, yung geological fault, yun, doon karamihan nangyayari yung mga fault, yung may mga gitak-gitak. At sabi nga, di ba, na it is not formed already. So, ibig sabihin, as the days pass by, nabubuo ito or nade-develop. So, yun. And dahil nga nag-iiba yung posisyon, tumataas naman po yung pressure ng energy. And sabi nga, geological faults are very disastrous. So, yun. May three types po ng geological fault. So, yun. Please remember this term po. The reverse slip fault, the strike slip fault, and the normal slip fault.
So next po is the man-made causing earthquake or human-induced earthquake. Na from the term itself, man-made, ibig sabihin, ang earthquake ay hindi nagaganap or nag-o-occur naturally tulad ng madalas nating nararanasan. Dito, ang earthquake ay nagaganap dahil sa mga activities na ginawa or ginagawa natin sa Earth's surface. So isa sa example ng man-made activity ay nuclear bombing, kung saan yung energy na na-produce mula sa pagsabog ng nuclear ay nagta-travel as waves sa Earth's surface which causes vibration na nararamdaman natin as earthquake. Aside from that, mining also causes earthquake. So paano? Di ba sa pagmimina, naghuhukay tayo sa ilalim ng lupa, which means nagkakaroon doon ng hollow part or butas. And kapag nagkaroon ng butas ang lupa, ang tendency ni crust ay i-fill yung gap kaya nagkakaroon ng pagguho. Nagkakaroon ng disturbance na nagkakos nga ng earthquake. Or minsan naman, doon pa lang mismo sa paghuhukay, nagkakaroon na doon ng disturbance sa crustal balance, nagkakaroon ng vibration na nararamdaman as earthquake. So addition pa po doon, meron din po tayong tinatawag na wastewater disposal na isa din sa man-made activity na nakaka-trigger sa pagkakaroon ng earthquake. Ang wastewater na tinatawag po ay yung mga toxic waste from oil fields na ang way ng disposal ay through injection ng toxic na yon sa ilalim ng lupa na if malapit po siya sa fault line, pwede siyang maging cause ng pagkalusen ng fault line. And pag nangyari yon, magkakaroon ng slippage and of course, ground shaking. Next po. So the next one is the minor causes ng earthquake. So dahil nga minor causes, meaning minor to moderate lang din yung magnitude ng earthquake na mapoproduce. Ang example ng minor causes ay landslide, avalanches, and collapsing ng heavy rocks. So katulad ng sinabi ko kanina, dahil nga nagkaroon tayo ng disturbance sa kalupaan, nagkakaroon ng contraction and expansion ang gases beneath the surface of the earth, nagpo-produce yon ng energy na nagiging dahilan ng vibration sa lupa at mahinang earthquake. Then nakalagay din dyan na plutonic earthquake. Ang sabi, plutonic earthquake occurs because of the adjustment in rock beds in the interior of the Earth's crust. Meaning, dahil nga sa nagaganap na contraction and expansion ng gases sa Earth's interior, nagkakaroon ng adjustment sa rock beds and yun yung pwedeng or yun yung magkakos ng earthquakes. Next po.
Okay, let's proceed to some example of earthquakes in the Philippines. Local muna. Pinili ko yung local compared to international. So we have the magnitude 8.0 earthquake happened in Mindanao on August 8, 1976. A magnitude 8.0 earthquake took place near Mindanao and Sulu a little past midnight of August 17, 1976 that was felt as far as Visayas. It was then followed by a massive 4 to 5 meters high tsunami covering 700 kilometers of coastline bordering the island. Because it was dark, the people were caught by the raging water which claimed 8,000 lives, enduring 10,000 and leaving 90,000 more homeless. So, ang casualties po ng nangyaring magnitude 8.0 earthquake in Mindanao noong August 17, 1976 is may namatay pong 8,000 na tao na may na-injure na 10,000 and meron naman pong 90,000 katao na naging homeless. So, doon po sa according to my research, according to Philippine Institute of Volcanology and Seismology, nung pong few minutes after the last stroke of midnight on August 17, 1976, a violent earthquake occurred in the island of Mindanao, spawning a tsunami that devastated more than 700 kilometers of coastline bordering Moro Gulf in the North Celebes Sea. So, it was an earthquake that resulted in massive destruction of properties and great loss of lives. So, in this slide, we have the 1976 Moro Gulf tsunami in Western Mindanao. Ito po yung naging effect po nung earthquake noong 1976, the Moro Gulf tsunami. So, in the Philippines, the worst tsunami event in history is the 1976 Moro Gulf tsunami in Western Mindanao. The tsunami devastated the coastline provinces bordering the Moro Gulf and the northern Celebes Sea. Tsunami waves may reported to be as high as 9 meters. Imagine, 9 meters in Lebak, Sultan, Kudarat. This tsunami was caused by a magnitude 7.9 earthquake with an epicenter about 96 kilometer. So, ibig sabihin, yung palang magnitude 8.0 is, kumbaga yung 7.9 is, kumbaga, mga aftershocks na yon. May mga aftershocks na nangyari before nung main earthquake. So, yung pagka magnitude 7.9 nag-effect po to into a tsunami. So, 7.9 earthquake with an epicenter about 96 kilometer off the coast of Cotabato. This tragic tsunami happened just after midnight when most people were already asleep. So imagine pag ikaw tulog at wala kang kaalam-alam na may mangyayaring tsunami, ay good luck na lang. So we have magnitude 6.9 earthquake in central Visayas happened February 6, 2012. Casualties, 51 people died, 62 still missing, and 112 were injured when 6.9 earthquake happened in central Visayas, particularly Negros and parts of Mindanao. So it caused a landslide which buried a barangay, damaged almost 15,483 houses, and casualties 383 million pesos on when it comes to infrastructures and buildings. Yung pong aftermaths na na-search ko po ay mamaya ko na lang po ipe-present after the presentation para po hindi po time consuming. We have magnitude 7.1 earthquake in Mindoro happened November 15, 1994. November 15, 1994 at around 3:15 a.m. a magnitude 7.1 earthquake rocked Mindoro. A gigantic 8.5 meters or as we convert 28 feet tsunami then followed which devastated the islands of Baco and Calapan, Mindoro. A total of 7,566 houses were washed out and some 78 people died because of the tragedy. So let's proceed on the tourist side of the or what we call the elastic rebound theory. Ano nga ba yung elastic rebound theory? Elastic rebound theory was originally proposed after the Great San Francisco earthquake in 1906 by the geologist Henry Fielding Reid to explain the deformation caused by earthquakes. Take note of this, yung elastic rebound theory ay originally proposed pagkatapos nung pangyayari doon sa naganap na earthquake sa San Francisco in 1906. Before an earthquake, the build-up of stress in the rocks on either side of a fault results in gradual deformation. Eventually, this deformation exceeds the frictional force holding the rocks together and sudden slip occurs along the fault. This releases the accumulated stress and the rocks on the either side of the fault return to their original shape or elastic rebound but are offset on either side of the fault. This is the figure. So in the first figure, we have the crust at rest. So we have no strain. And the second, we have the crust deformation. So strain accumulates. So incipient fractures possible and strain build up pwede mangyari. So in the third, we have ruptured crust causing earthquake. Dito na po pwedeng mangyari na mag-break po yung pinaka-crust po, yung two boundaries. On the last, we have the fractured crust or dito na po na-perform yung fault line na tinatawag natin wherein strain release. Mayroon pong ginamit na material si Henry Fielding Reed to further explain the elastic rebound theory at iyon po ay ang paggamit po ng rubber band. Sinasabi po dito that from an examination of the displacement of the ground surface which accompanied the 1906 earthquake, Henry Fielding Reed, professor of geology at Johns Hopkins University, concluded that an earthquake must have involved an elastic rebound of previously stored elastic stress. So as we stretch the rubber band, possible na mag-broken ito or maputol. So elastic energy is stored in the rubber band. But during the stretching, it will suddenly be released. So similarly, pwede nating ikumpara ito sa Earth's crust. So Earth's crust of the Earth can gradually store an elastic stress that is released suddenly during an earthquake. So yung palang crust ay meron ng stored elastic stress, and when earthquake occurs, elastic stress release. So this gradual accumulation and release of stress and strain is now referred to as the elastic rebound theory of earthquakes. Most earthquakes are the result of the sudden elastic rebound of previously stored energy. The elastic rebound theory is an explanation on how energy is spread during earthquakes. So as rocks on opposite sides of a fault are subjected to force and shift, they accumulate energy and slowly deform until the external strength is exceeded. So in geology, yung pong elastic rebound theory was the first theory to satisfactorily explains earthquake.
So what are faults? A fault is performed in the Earth's crust as a brittle response to stress. Generally, the movement of the tectonic plates provides the stress, and the rocks at the surface break in response to this. Faults have no particular length. So, aware naman tayo dun sa West Valley Fault na naka-incline sa the big one, which is predicted 7.2 in magnitude na nasa Manila. Na-predict siya because of the fault line, and makikita natin sa hazard map kung ano yung mga tatamaan. So during an earthquake, alam natin na gumagalaw ang lupa, and yung rock on one side at the fault suddenly slips with respect to the other, causing cracks. So next. What causes faults? Stress is defined as a force exerted over an area. In geology, stresses relate to tectonic plates, enormous slabs of rock that lie underneath all the world's land masses and oceans. Tectonic plates aren't motionless, however, they shift positions, and in doing so, stress builds up along their borders with other plates. If the stress is not equal from all directions, which it often isn't, rocks can bend, twist, and break. This often happens because along fault lines at the edges of plates, which is why earthquakes tend to occur in this zone. So, kung ang rocks ay may friction para hindi gumalaw, and once yung friction na yun ay hindi nakayanin, then magsimulang magkaroon ng movement, and which is defined by stress. So, ano nga ba yung mga stress na yun? Next po. So, there are three main types of stress. The first one is the tensional stress. This is when slabs of rock are pulled apart. Makikita naman natin dun sa mismong picture. Before the stress, original landmass, plain lang siya. Nagkaroon ng stress. So, mas stretch yung rock kasi pulled apart. Best example niyan is yung Pangaea, which is alam naman natin na dati siyang supercontinent, at dahil sa paggalaw ng lupa, nag-pulled apart siya, resulting now into 7 continents. So the second one is the compressional stress. So yung compressional stress naman is the opposite of tensional stress. Compressional stress is when slabs of rock are pushed together, compresses. So ang ano naman yan is kapag yung mga rock, kapag gumalaw ang lupa and push together, dyan nagpo-form yung mga mountains. So, another one is yung shear stress. Sa shear stress naman is when slabs of rock slide past each other horizontally in opposite direction. Nakikis-kison siya. The rocks are not smashed into each other or pulled apart, but their edges slide along each other with a lot of friction. This is like when you rub your hands together to warm them up. One hand goes forward and the other goes backward, rubbing against each other. So, yun pushes crust away from different directions. Large part ng crust kapag nag-move ay nabe-break into smaller pieces, turning smaller portion ng plates, and yung friction ng shear stress sa mga edges ng plates might cause earthquake. So, yun.
Types of fault. These type of faults are deformed caused by the type of stress, which also tells us about how the fault moves. Faults have two sides, which is the hanging wall and the footwall. These terms came from the miners because you can stand with your feet on the footwall and hang a lamp on the hanging wall on the opposite side. But the reverse situation would be impossible. Okay. Tensional stress, it is occurs at the divergent plate boundaries, meaning rocks pulling apart from each other creates a normal fault or space. As you can see with the normal faults, the hanging wall and footwall are pulled apart from each other and the hanging wall drops down relative to the footwall. The normal fault came from the miners in Germany who noticed that most of the faults where they were working were of this nature, so they called them normal, meaning typical. The two well-known regions where normal faults are spreading apart Earth's crust are the Basin and Range Province in North America and East African Rift Zone. Second, compressional stress. It occurs at convergent plate boundaries, meaning rocks pushing into each other or has the effect of squeezing and shortening the terrain that creates a reverse fault. In this type of fault, the hanging wall and footwall are pushed together and the hanging wall moves upward along the fault relative to the footwall. This is the literally reverse of the normal fault. Reverse faults tend to form a scarp. So, ano nga ba yung scarps? It is the piece of rock that has been thrust up or higher than the original surface level. The Rocky Mountains, the Canadian Rockies, and the Appalachian Mountains are all examples of the types of features created by the reverse faults. Shear stress, that is next slide po. Shear stress, it occurs at boundaries where two plates are sliding sideways past one another. It is like the cars traveling in an opposing lanes on a highway. Friction between the plates grinding past one another produces stress. Shear stress is associated with transform faults, which may also be called strike-slip or slip-strike faults. The most well-known example of shear stress is the strike-slip fault known as the San Andreas in California. Strike-slip faults are usually vertical, while normal and reverse faults are often at an angle to the surface of the Earth. These different styles of faulting can also be combined in a single event, with one fault moving in a both vertical and strike-slip motion during an earthquake. There are many geological faults in the world created after natural changes and events. The two of the most famous are the San Andreas Fault. It is a continental transform fault that extends roughly 1,000 to 200 kilometers or 750 miles through California. It forms the tectonic boundary between the Pacific Plate and the North American Plate, and its motion is right lateral, strike slip, or horizontal. The fault divides into three segments, each with different characteristic and a different degree of earthquake risk. The slip rate along the fault ranges from 20 to 35 millimeter or 0.79 to 1.38 inches per year. It is famous for producing large and devastating earthquakes. The next one is the Altain Tag Fault. It is a fault that was created and continued to exist for about 40 million years ago. That is 2,000-kilometer long active sinistral or left lateral strike slip fault that forms the northwestern boundary of the Tibetan Plateau with the Tarim Basin. It is one of the major sinistral strike slip structures that together help to accommodate the eastward motion of this zone of thickened crust relative to the Eurasian plate. A total displacement of about 475 kilometers has been estimated for this fault zone since the Middle Oligocene, although the amount of displacement age of initiation and slip rate are disputed. This fault is probably the biggest active fracture in the world. And did you know that the Earth's biggest exposed fault is the Weber Deep, which has the scientists have been aware that it has a 4.47 mile deep or 7.2 oceanic abyss. It is located at the coast of the eastern Indonesian in the Banda Sea, but recently they had been unable to explain how it got so deep. So,
And for our conclusion on what we've discussed today, earthquakes have devastating effects on our communities around the world. Not only do they result in casualties, they can cause damage to vital infrastructures, housing, and other basic services. So it's important that city planners and construction companies think about potential future earthquakes when they plan and construct buildings. So this, di ba may pinag-aralan tayo mga wind loads, dead loads, live loads. Also, we can consider the earthquake loads. Yun lang. And that's all. So, meron nga pala akong papanood sa inyong aftermaths nung nangyaring, yung pinakamalakas na earthquake na nangyari dito sa Pilipinas. And this, Aba. Wait lang. So, magpapalaro kami. And I expect na meron kayong dalang another device na magagamit for the game. May sinend ako ditong link. Dito kayo papasok. Wait lang, present lang ako.
Participate everyone na lang po.
Ito yung code na ano nyo. Type. Ang link ay nasa comment section. We have may isa na tayong participants. 2. Bali 27 tayo dapat. Kulang pa ng dalawa. Ay, hindi pala. Double device pala ako. So, kompleto na. Okay, start ko na. Ready na ba lahat? Paki-raise ng hands ko, ready na lahat. Yun, nangunguna. So, i-explain ko lang kung yung point system. 600 points for getting it's correct and 0 to 400 points based on speed. So, based sa speed ang inyong makukuha score. So, ang incorrect answer is always 0 regardless of speed. Okay, next question na tayo. Yun, nangunguna na si Jill. Next question. So, ang 6 to 10 ay may 10 seconds duration na lang. So, pabilisan na lang ha. Oh, nangunguna si hello. Next question. Lupit naman hello. Last question. Ay, hindi pala. Hindi pala. Last question for this quiz. Wow. So, third is hello, second is Gael, and first is John. Congrats to John. Paki-message na lang. Yun, kung sino man si John, ay paki-PM na lang. Paki-PM na lang si Cheryl Lee. Sir, tapos na po.
So, hello po. Kami naman po yung group na mag-report ngayon.
Recorded.
Okay, so comment for the first reporter. So maganda naman. At least yung sa una, parang nagka-preview sila. Tawag dito. Review nung topic natin last meeting, yung introduction to earthquake engineering. And then yung mga slides sila, ayun, binabasa nila, pero yung discussion, i-discuss nila ng bukod. It's okay. And ayun, naghanap rin naman sila ng video na okay? So far so good. Congrats. Palakpakan naman natin. Virtual applause to our first reporter. Okay, next, group number 2. So guys, yung first reporter, pasan na lang ng report ha, sa email. Ayan. Para ma-upload ko rin sa inyong LMS. Next. Group 2, pero bago yan, mag-record lang ako ng isa pa.